In most science fiction films, threats to space travelers usually deal with aliens, asteroids, and a host of other menaces. But in reality, one of the biggest threats to space travelers is in fact radiation. That's why it's imperative that NASA researchers focus on finding ways to shield astronauts from exposure. I spoke with Dr. Francis Cucinato at NASA Johnson Space Center to find out more.
Shielding, one of the things you should think about is that you don't have to shield the entire spacecraft, that you can shield just portions of a spacecraft where you could locate astronauts during a solar storm. The solar storms last from 1 to 2 days, but the peak of the radiation is only over about an 8-hour time frame. So you can save a lot of cost in launching mass by locating the astronauts in one place within a spaceship or a habitat on the Moon or Mars. And then in that localized region we can have extra shielding, and there we can also use better materials. So the materials like aluminum are a typical spacecraft material. They're very sturdy, easy to use, but they're not the best materials for shielding. So in these localized areas of a spacecraft, we would plan on using a material with a lot of hydrogen in it. So hydrogen turns out to be the best material for stopping ions as they pass through the material.
Can you explain how radiation will affect the astronauts?
One of the things that's important when you look at radiation effects is that it's a game of risks. So like any other risk, like driving your car or taking an airplane flight. So you really have to stop and say, well, is it worth it to take the risk? So when you look at that question, there's two things that come to mind. One is, what am I doing? So you think, well, I'm going to discover life on Mars, so it's obvious that you will take risks. So you'll accept the risk of radiation. But the other part of the coin is, what is the risk? Because now NASA or the families of an astronaut, they want to know what the risk is, and some of the astronauts too want to know what the risk is. On a space shuttle mission, the risks from radiation are very small. So even if we're off in our predictions by a lot, there's really no outcome to that, or bad outcome. When you go to the Moon or to Mars, we know that the risk from radiation is going up. So now the point is that the accuracy of our prediction becomes more and more important as the risk is expected to get higher and higher. This is the basic physics and understanding of these processes has been developed along with the knowledge from us understanding space radiation effects.
What are some of the preventative measures you're taking for astronaut safety?
We're looking into ways to prevent radiation effects through countermeasures. And the key to countermeasures is knowledge. So if we look again at this problem of going from genetic damage or tissue damage to late effects like cancer, we believe that the way you can prevent this is understanding the whole problem from top to bottom, and then looking for an opportunity to intervene and prevent the cancer from growing. So that this has obvious benefits on Earth. One area we're interested in is that it turns out that the ends of chromosomes, which are called telomeres, if they're lost through a radiation event, the deletion of the telomere, that this is one of the mechanisms that causes cancer. So we're looking now at mechanisms that you could use with the drugs or other biological countermeasure, biochemical methods to prevent the loss of the telomere from radiation. But telomere loss is not only occurring with radiation damage, it's also occurring from cigarette smoking and poor diet. So there's a whole bunch of other areas where protection of telomere damage would be applicable on Earth.
How do you not get frustrated dealing with so many unknowns in your research?
Well, that's the most fun part of the job, is that you're doing something that's unknown, it's new. So it's sort of like discovering, a voyage of discovery, like going into space, that you're trying to look at what's really happening to people when they're exposed to radiation at the very most basic level. You have to really go down to DNA, the physical interactions of radiation with DNA, and how DNA, when it's changed, leads to disease. So these are really basic science questions, and we've come to understanding that that's the only way we really can protect the astronauts, because if you use a method that's empirical, meaning there's a lot of assumptions and things that you really don't know, but you'll just skip over that you can actually make very life-threatening mistakes in the end. So you really need to go to this very basic approach and understand the whole problem from top to bottom.